Today I am going to explain to you the most important chapter in class 12th, that is solutions. Solutions, it is the second unit. It is the most important topic. So before going to discuss this chapter, we will discuss about topic wise analysis of last 10 years CBSE board papers. So whatever the year you take, so generally 5 marks question or 3 plus 2 or 3 plus 1 plus 1. Total weightage from this chapter is 5 marks. So whatever the question, that is maybe 5 marks or 3 marks or 2 marks, the generally maximum total weightage is of colligative properties and determination of molar mass. So this colligative properties, this topic is very important. So very short answer type questions were asked from colligative properties and determination of molar mass. That is short answer 1. That means 2 marks type questions also from colligative properties, determination of molar mass, ideal and non-ideal solutions. Another short answer type, that is 3 marks questions also asked from colligative properties and determination of molar mass. So from this analysis, it is clear that the colligative properties and determination of molar mass is the most important topic from this chapter. So what I did here, this entire chapter I divided into 11 parts. So in first part I will discuss about introduction of solutions and classification of solutions. In second part, concentration terms. What are the concentration terms used to measure the concentration of solutions? So in third lecture, I will going to discuss about numericals. I will solve some numericals on concentration terms. In fourth part, solubility. What is meant by solubility? How solution is formed? What are the thermodynamical factors involving in solubility? Next, in fifth part, Henry's law and applications and numericals. In sixth class, vapor pressure concept and Raoult's law of volatile liquids. In seventh part, ideal and non-ideal solutions and deviations, positive and negative deviations and azeotropes. Next, in 8th class, colligative properties. What is meant by colligative properties? What are the types? After that, relative lowering of vapor pressure, and based on relative lowering of vapor pressure, numericals are discussed in lecture 8. In lecture 9, elevation in boiling point and depression in freezing point. These 2 factors completely discussed in this class. Now lecture 10, what is osmosis, osmotic pressure and reverse osmosis and applications and related to osmotic pressure, numericals also discussed in this same class 10. So finally in lecture 11, all numericals related to different topics from NCERT textbook explained in this lecture 11. So in this 11 lectures, I covered all the topics including JEE and NEET topics also included in this entire 11 classes. Now first we will see first part. In this one, what is meant by solution? That means introduction. How solutions are classified? That means classification of solutions we are going to discuss. Now in normal life we rarely come across pure substances. You know, from class 9th you studied what is meant by pure substances. In normal life, we rarely come across pure substances. We are rarely getting pure substances. But most of the substances we are using, most of the substances we are seeing, that are mixers. Mixers are of 2 types. You know that mixers are of 2 types. What are that mixers? Homogeneous mixer and heterogeneous mixers. Mixers are of 2 types, homogeneous mixer and heterogeneous mixer. What is meant by homogeneous mixture? Uniform composition throughout the mixture. Throughout the mixture, you can see the composition is same. It is non-uniform composition. Now I will ask one question to you. Give some examples. Give some examples for homogeneous mixtures. Give some examples. What are the examples for homogeneous mixture? What are the examples? Now, yes, what you are telling? Alloys. Alloys like brass, bell metal, steel, bronze. So, like this, you take this steel bottle, it is a mixture. It is a mixture of two solids. So, it is an alloy example. Alloys like brass, bell metal, steel, bronze, etc. Not only this one, this is one point here discussed. 1 ppm of fluoride ion in water prevents tooth decay. Fluoride F minus ion in water, 1 ppm, 1 part per million. If 1 part per million of fluoride ion in water prevents tooth decay. So if 1 ppm is there, your tooth will become like this. 1 ppm of fluoride in water. Fluoride in water. That means it is a mixture. Fluoride in water, it is a mixture. If it is 1 ppm, then it prevents tooth decay. If it is more than 1 ppm, that means 1.5 ppm of fluoride ion in water causes the tooth to become mottled. If fluoride ion concentration is more in water, tooth will become like this. If high concentration of fluoride in water, if it is more than 1.5, then what will happen? Then water will become poisonous. So fluoride ion's concentration, if it is more, it will become like, it can be used as poison. You can see here, rat poison. Rat poison contains sodium chloride. Rat poison contains sodium chloride, NaF. Now I discussed here, high concentration of fluoride in water poisonous. But you can see in some areas of our country also, one disease is there, fluorosis. What is fluorosis? Fluorosis is a disease. What is fluorosis? If water contains fluoride ion concentration is more than 3 ppm. If more than 3 ppm, water, fluoride ion concentration is greater than 3 ppm, then bones becomes weak and the teeth becomes yellow. This type of disease is called fluorosis. You see number of people affected by fluorosis in India, in Rajasthan, Telangana, Andhra Pradesh, Madhya Pradesh, Bihar, Uttar Pradesh. Here statistics given. Because of fluorosis, bones becomes weak and the teeth becomes yellow because that fluoride ion reacts with calcium present in our body. So this type of disease is called fluorosis. Now you will see some questions related to this topic. Now I discussed that one. You see the question, the importance of many pure substances in life depends on their composition. Which of the following statement justify the above fact? 1 ppm of the fluoride ion in water prevents tooth decay. Is it correct or not? 1 ppm of fluoride ions in water prevents tooth decay. If it is 1.5 ppm of fluoride ion causes tooth decay, concentration above 1.5 ppm can be poisonous. All of the above. Which one is correct? Yes. Fourth, D is correct. Now you see second question. Which of the following fluoride is used as rat poison? Now only discussed which substance is used as rat poison. Sodium chloride. That means NaFC. Now you will see next. What is meant by solution? Now where I started, in our daily life we are getting very less number of pure substances. We are using only mixers. Mixers are of two types, homogeneous mixer and heterogeneous mixer. So from homogeneous mixer only this term will come solution. What is solution? Homogeneous mixture of two or more substances in single phase. The homogeneous mixture of two or more substances in single phase is called solution. Example for some solutions: brass. Brass is a mixture of copper and zinc. Brass is an alloy actually. It is a mixture of two metals, copper and zinc. So similarly, German silver is an alloy which contains three metals, copper, zinc and nickel. So German silver also is a mixture, homogeneous mixture of three metals that are copper, zinc and nickel. So these are alloys. Now you will see formation of solution is a physical change. I already told homogeneous mixture of two substances. You add some sugar in water, then there is no reaction between sugar and water. Just dissolution of sugar in water only will take place. Dissolution of sugar in water only will take place. So it is only physical change. Total number of pages in solution is 1. Before mixing, sugar is 1 page, water is 1 page. After mixing, you can see only 1 page, single page. Total number of pages in solution is 1. Total number of components in solution is how many? Total number of components in a solution is question mark. It varies from solution to solution. If only two components are there, then that solution is called binary solution. If solution contains only two components, for example, you take sugar and water. Sugar is one component, water is one component. This type of solution is called binary solution. You take mixture of sugar, water and salt. Sugar, water and salt. How many substances are there? 3 types of substances are there. Number of components are 3. Then it is called ternary solution. 4, quaternary solution. So number of components in a solution, it will vary from one solution to another solution. It depends on number of components. Now you take solution. In this solution there are particles there. With red color I marked some particles and green some. Which number is more? Red colored particles number is more. So that means a large component is this one. This large component is called solvent. Small component, green colored, only 5 particles I placed here. So this small component is called solute. Solution contains a binary solution. If it is a binary solution, it contains only 2 components. Binary solution contains only 2 components. One is solvent, another one is solute. Components of binary solution: solute and solvent. What is solute? From this picture it is clear. What is solute? Less number. What is solvent? More number. Solute, so usually the lesser amount, the part of a solution that is being dissolved, that means small component, is called solute. The part of a solution that dissolves the solute, that means that provides a medium, that is called solvent. Generally, while notation, you have to remember during solving of numericals, solute you will denote with a small s, solvent with a capital S, because it is a smaller component, small s, large component, capital S. In the same way, if you are using 1 and 2 names, 1 and 2 terms, if it is number system, for solvent you are giving priority 1. So suppose mass of solvent W1, mass of solute W2. If you are using A and B system, weight of mass of solvent is WA, mass of solute is WB. So small component is called solute and large component is called solvent. It is a binary solution. Next one, types of solutions based on physical state. Types of solutions based on physical state of solvent. So based on physical state of solvent, solutions are classified into 3 types: solid solution, liquid solution and gaseous solution. Based on the physical state of solvent, Solutions are classified into three types: solid solution, liquid solution and gaseous solution. Now what is meant by solid solution? If solvent is solid, then that solution is called solid solution. If solvent is liquid, then that solution is called liquid solution. If solvent is gas, then that solution is called gaseous solution. Based on the physical state of solvent, solutions are classified into three types: solid solution, liquid solution and gaseous solution. If you take the physical state of solute also, then this solution, these three solutions will become 9 solutions. 3 into 3, 9 types, like this. So total types of solutions are main 3 types. Gaseous solution means solvent is gas. Solute may be gas or liquid or solid. Liquid solutions means solvent is liquid. What about solute? Solute may be gas, solute may be liquid, solute may be solid. Third category, in solid solutions, solvent is solid and solute may be gas, liquid or solid. So that means based on the physical state of solute and solvent, entire solutions are classified into 9 types. So this type of classification in lower classes also there. In class 9th you studied, there are types of colloids. In types of colloids also all these varieties are there, except only one, that is gas in gas. Other than gas in gas, all types of colloids also possible. In types of solutions, 9 varieties are there. Now we will see how many gaseous solutions are there. Gaseous solutions are of 3 types. What are the 3 types? Gas in gas, liquid in gas, solid in gas. In gaseous solutions, what is the solvent? Gas is the solvent. We will see first one is gas in gas. That means solute is gas, solvent also gas. It is the homogeneous mixture of gases. That means one gas is solute, another gas is solvent. Both homogeneous mixture. What is that mixture? Oxygen and nitrogen. You can take oxygen and nitrogen, that means air. Air mainly contains nitrogen, that is 78%, oxygen, that means 21%, total 99%, these two are there. So remaining 1%, CO2, moisture, ozone, hydrocarbons, all types of pollutants, that is including noble gases, that is about only 1%. If you take air is a binary solution. That means you consider only two components in air. One is nitrogen and oxygen. Then both are gases. So which one is large component? Nitrogen is large component because its composition is 78%. What is the percentage of oxygen? 21%. That is solute. So solvent is gas, solute is gas. Both are gas in gas type solution. It is gas in gas. That means air. Next one is liquid in gas. Chloroform. Generally you know chloroform, it is used as anesthesia. This chloroform is a liquid, nitrogen is a gas. This chloroform and nitrogen both mix in this vessel, in this container, both mixed. So both gives an homogeneous mixture. This homogeneous mixture contains one is liquid, another one is gas. Which one composition is more? Which one percentage is more? Nitrogen. Nitrogen is gas solvent. Chloroform is liquid solute. So it is liquid in gas. Third variety, camphor. Camphor is a solid. You can keep that camphor in the atmosphere of nitrogen. You take one container nitrogen, in that you keep camphor. After some time it forms homogeneous mixture. It contains solid camphor and gas is nitrogen. Similarly, liquid solutions are of 3 types. Liquid solutions are of 3 types. You take, what are the liquid solutions? Gas in liquid, liquid in liquid, solid in liquid. In these 3 varieties, Three varieties. What is the solvent? What is the solvent? Liquid. What is the solute? Solute is varying here. Gas, liquid, solid. First one is gas in liquid. Gas in liquid, you take water in sea water or aquarium, whatever, wherever you take, this water is a liquid. Solvent composition is more, solvent percentage is more. But this water contains some gas, oxygen, dissolved oxygen. Oxygen is dissolved in water. So that's why this aquatic life survival taking place. So this water contains one gas. Gas is dissolved in liquid. Gas in liquid. So this is an example for first type. Second one's liquid solutions. Liquid in liquid. Generally, everybody knows this type variety, this variety of solution. Generally, you are also thinking solution means it is a mixture of two liquids. Ethanol. Ethanol is a liquid. Water, you mix ethanol and water, liquid and liquid. Ethanol and water forms homogeneous mixture. It is liquid solution, liquid in liquid type. Now you dissolve glucose in water, sugar in water, salt in water. So solid in liquid, solid in liquid. Next one is solid solutions. Solid solutions are of three types. You take these solid solutions. What is the solvent? Solvent is solid. Solute, it may be gas or liquid or solid. First one is gas in solid. You take hydrogen gas. What is the solid? Palladium. The mixture of hydrogen gas and palladium. In the crystal lattice, in solid state chapter you already learned, in crystal lattice metal atoms, all palladium metal atoms. In these gaps, in this gaps, this hydrogen occupies and forms a homogeneous mixture. This homogeneous mixture is the mixture of hydrogen and palladium. You can consider is a solution of gas in solid. Second variety, liquid in solid. Liquid in solid. So all types of amalgams. What is meant by amalgam? What is meant by amalgam? In this mixture, if one component is mercury, then it is called amalgam. One component is mercury, another compound is sodium. Mercury and sodium, liquid and solid and liquid. So it is a solution of liquid in solid. So mercury is a liquid, sodium metal is a solid, liquid in solid type. So these are called amalgams. You give one more example for amalgam, sodium amalgam, zinc amalgam. Zinc metal is mixed with mercury, zinc amalgam. Next one is all types of alloys. Already starting only given these examples. All types of alloys. All types of alloys. You take copper metal plus gold metal. It is a solid. It is also solid. These two solids form a homogeneous mixture, that is ornamental gold. Ornamental gold is the mixture of copper and gold. Solid and solid. Solid and solid. You cannot prepare these ornaments by mixing this copper and gold direct. How to prepare these ornaments? How to prepare alloys? You have to mix the two metals in molten state only. In molten state. So total 9 varieties I given in the form of table. You can see this table in your textbook also. Now we will see some MCQs related to this concept. Most of the process in our body occurring. In our body so many mixtures are there. So many reactions will take place. In what form? Solution, solid or liquid or gaseous or collider. In what form? Almost all the process in our body occurring liquid solution. So option B is correct. You see next question. The term homogeneous mixtures signifies that. The term homogeneous mixture signifies that its composition is uniform throughout the mixture. Its properties are uniform throughout the mixture. Both composition and properties are uniform throughout the mixture. Neither composition nor properties are uniform throughout the mixture. What is the correct one? Yes. Answer C is correct one. Both composition and properties are uniform throughout the mixture. Next question is, which of the following mixture are called solution? Water and ammonia, water and acetone, acetone and alcohol, hexane and water. Here 4 mixtures given, water plus ammonia, you can see in lab ammonia solution, liquid ammonia, ammonia solution, water plus ammonia, water plus acetone, acetone plus alcohol, hexane plus water. Here some ABCD options given. So in this which one is forms solution? Here 4 out of 4, which one forms solution? So answer is A. 1, 2, 3. Water plus ammonia, it gives homogeneous mixture. Water plus acetone, acetone plus alcohol. Acetone and alcohol both are organic compounds. They will soluble. Water and acetone are also soluble. Water and ammonia are also soluble. But hexane and water are insoluble. Why? Because hexane is an organic compound. Water is a polar solvent. What is the principle? Like dissolves like. Polar compounds, that means ionic compounds, are soluble in polar solvents like water. If ion is there, like dipole, at least dipole attraction is there, then it will soluble in water. But here hexane is an organic compound, so it is insoluble in water without pore. What is the option? A. So answer A is correct. Next question. Match the columns. Here some mixtures given: sodium amalgam, hydrogen gas in palladium, camphor is a solid in nitrogen gas, oxygen dissolved in water. So based on physical state, here some column, another column, physical states given. Now you try to give the correct set. So you try for this answer. Yes. So answer is C. Next question. Match the columns 1, 2, 3. Here types of solution: gaseous solution, liquid solution, solid solution. Next one, solid liquid, solid liquid gas. Here some mixtures given: copper dissolved in gold, chloroform mixed with nitrogen, common salt dissolved in water. All these mixtures now only I explained. Based on that, just which option is correct, you check it. So what is the answer? B is correct one. Now some NCERT text questions related to today's class, that is, define the term solution. How many types of solutions are formed? Write briefly about each type with an example. It is the first question in our NCERT textbook. So what is the first question? Define the term solution. The homogeneous mixture of 2 or more substances is called solution. How many types are there? Total 9 types. Write briefly about each type. You sort out and write the notes for this question. Second one, give an example of a solid solution in which the solute is a gas. Solvent is a solid, palladium. Solute is a gas, that means hydrogen. The mixture of hydrogen in palladium. That is the answer. Okay, thank you. We will meet in second video.